Hello everyone, this is the video lecture for Calculus 1, Section 5.1, Area and Distances. What we're doing in Chapter 5 in general is integrals. So I want to talk about integrals for just a second, and then we'll come back to this topic they're specifically talking about. So integrals, and we've kind of already seen this from the last chapter in last section in chapter 4, I believe. But regardless, let's talk about it now. Let's just say I have like the integral of x squared dx, something kind of basic. And so the formula to get these antiderivatives, as they call them, or the integrals, is to add 1 to the power and then divide by the new power. In this particular case, because you don't have numbers here with the integral sign, that big old S, again, that means summation, because you don't have extra numbers, you're just going to put a plus C. C stands for constant, some other constant in there. And I believe that I talked about all that in the last video. If I didn't, well, we'll see it again. We're not doing that here today, but at least we're going to see that again eventually. Let's just say that we had something else. I'm just going to make it up, an x cubed, let's say. And then let's do 0 and 1. And so, again, add 1 to the power, divide by the new power, and I'm going to go from, that's the win bar, like W-H-E-N, win bar. So when we have x equals 0 and x equals 1, or from 0 to 1, that kind of thing. What you do here is you plug in the 1 first, so you get 1 to the 4th, divide by 4, and then you put a minus sign between it, plug in the 0, 0 to the 4th, divide by 4. You can see that we get 1/4 minus 0, and that is a 1/4. Cool. And you don't do a plus C because this is called a definite integral. You have definite lines that it starts and ends at. The indefinite integrals, you have to put a plus C. And so that would be your answer that you would type in WebAssign for something like that. This is what integration truly is. This right here is what you will be doing eventually. In this class. This is what you will be doing full-time in Calculus 2 and Calculus 3 and all those kind of things. Integrals are a very important topic. And what I see is that 5.1, 5.2, 5.3, and 4, I think, all the way up till 4, do not actually do what we're doing here. They don't. And that's very sad to me. So I'm going to give you a disclaimer here. I'm going to do a big disclaimer. Disclaimer is that the book does not teach this well. That's just my opinion. Okay, maybe the book proper might. I don't know. I don't read the book. But what the book spits out here for your homework, because I don't make your homework, is not a very good way to teach it, okay? So what I'm doing is I'm going to be doing problems with you that are on the homework. I think that some of them are good problems. I think most of them are not needed, but that's my disclaimer. I still want to do them with you because obviously they're important for you to get a passing grade in the class. But in the end, a lot of the concepts are stuff that you will see and then you'll not see again for a while, if ever anymore, and we move on. It's a nice core setup, but in my opinion, it's just gone about differently, okay? I like this, and you're going to like this, and this is what everyone's supposed to be doing from here on out. So until then, we're stuck in math prison. There you go. So 5.1, math prison. Okay. In 5.2, math prison. 5.3, math prison. All right. Sorry. Just my opinion. So let's get started on some problems that have nothing to do with this. Completely different. We got a T and a V, and they give us 0, 0.5, 1.0, 1.5. I could type this so much faster than writing it, and it would be much more legible. But that's okay. We're going to get through this. 0, 5.7, 11.2, 14.1. The points are the hardest thing to do with the stylus setup. It just does not detect very small movements. And then 20.0. All right, so we got some numbers up there. And they say find the lower and the upper limits for the distance traveled. I mean, really, they couldn't have done this worse. This is not a very good first question. I would have to explain concepts for quite a while. And so we're given a velocity. What they're wanting is actually a distance, which means that we're going to have to go the antiderivative. See, so your distance, when you take a derivative, it becomes a velocity. And so this is how we often do S. It goes to V, or S prime is equal to V, that kind of thing. Well, what we're needing to do is we need to go backwards. So antiderivative, which of course means integral, which of course means sum, which of course means summation. And so we're going to end up with a summation I equals something to something, and then with something else here, you add them all up and you call it a day. That's at least the theory side of things with this problem. The application is actually much easier, and I will show you. So we got lower, and we have upper. And your lower will be a smaller number. Your upper will be a bigger number. And what they're wanting to find is add up all of these numbers, but remove the endpoint. And then you're going to add up, I'm going to use a different color. And then you're going to add up all these numbers here by removing one of the endpoints. You can kind of see already that this will be your upper, simply because it's got a bigger number in there, while this will probably be your lower. It's not always left side on the lower. It just kind of depends on what's looking at what you're seeing here. But I'm just going to add up all these points. I'm going to divide by the interval distance, which is, again, if you could see, I'm changing by 0.5 each time. And so that's my width. And that would be your answer. So 0 plus 5.7 plus 11.2, 14.1, 18.8, 19.8. All right, so we got all those numbers. And I'm going to multiply it by the 0.5, which is, again, a width. And so these here are heights. That's a width. And then you go ahead and get your answer. I'll go ahead and give you your answer. It's 34.8. Now, what was going on here? So I do not know how all this shape is. I'm just going to make up a curve, okay, something like that. And let's say that cuts it off at the 3.0 like we had there. What we're creating is small little rectangles to fill in like this. Again, they're rectangles. Something kind of like this. Again, I'm not 100% sure what it looks like, but it's something like that. You're adding up all the heights, and you're going to multiply by the distance, the width of each one of these rectangles, which you could see would be a 0.5 in this particular case. And so I'm adding up all these here so I can find an area which that is equal to the integral. Okay, so this is the same thing. An area and an integral are the same thing. Okay, so that's so much theory. But the application is very simple. Now, I just do the same thing over here, except I'm going to add the 20 and get rid of the 5, or get rid of the 0. And so let's just finish this problem out. I'm doing problems that are weird, that are strange, that I've had people ask me in the past, say, hey, what is this problem? What am I supposed to do here? How do I... The main focus of these videos in particular is going through the homework problems that are strange. You could see that this will be your upper for sure because it's bigger. Now it's your lower because it's smaller. So that's what you do on this problem. Again, I don't think they do a very good job of theory, or at least even supporting the theories that we're supposed to be learning in this section and stuff. So, oh well, we just do what we can. All right. So here's a graph, and they're wanting L6, R6, and M6. I mean, I'm very happy that we're learning these concepts, but this is a fleeting concept. Yeah, we'll use it in Cal2 about 2 more times in your life, but and it's a good fundamental understanding. but in reality, this is not what integration is going to be for you on a day-to-day basis, okay? What they're wanting is the leftmost side rectangles, the right side rectangles, and then the midpoint rectangles. What does this mean? So, and they say in particular, they say 6 rectangles. That's what that 6 is right here. So I'm going to have to split this thing up into 6 subsections. There you go. So my left rectangles are going to take from the heights from the left endpoints. And so here, I know right now they look about the same. But as we keep going, it should do this. See how I'm starting on the left side? There you go. I'm starting on the left side and I go over. Start on the left side, go over. Start on the left side, go over. And so we got 6 rectangles. I want to add up their heights. I'm going to multiply by the distance between there. And if you take that 12 divided by 6, you'll see that there's a 2 distance, a 2 width for each of those. And there we go. Here's the problem. They don't actually give you real numbers. They'll just say, here's your graph and figure it out. The grid is not exceptionally great. It's very hard to see. And so you're just going to be guessing. You're going to be guessing on a lot of these heights. Some of these are easier to see than others, but most of them you'll be guessing. Let me go ahead and guess for you so that we're all in the same place in guessing mode. I'm making up these numbers. These are from the graph. I look at the graph. I say, hey, that looks like it's about this big. Right here is 9. Right there is 8.75. Here's 8.25. Here's 7.25. Here's 6.0. Here's 4.0. Yep, this is definitely 4.0 right here, guys. Definitely. I mean, I'm not 100% sure. I don't know. I'm just doing the best I can with what they've been giving me. And I put all this through, and I got 86.5 for mine. And they have an 86.6 as their answer. Now, how are you going to get the right answer every time? Well, I think that there's a little bit more error tolerance than what you think. And so these two here, this one should be fine. I'm not worried about 86.5 versus 86.6. WebAssign should have a little bit of plus minus error margin on this. And so I'm not worried about that. Let's do the right endpoints. And so what we're going to do now is start on the right side and make little rectangles for those. Let me use a different color. Blue is something we already used up there. So on the right side, on the right side, on the right side, right side, right side, right side. And so you could see actually that we're going to get a smaller set of answers. Notice that like right here, so like all of this and this is green, but the red was bigger. So it's going to be a smaller answer for the rights. And that's okay. You're going to reuse most of these numbers anyways. And so I'm basically just taking all of these numbers, and then there's like another number over there. Very, very, very similar to that very first problem. So I am just copying these numbers down because I already did the math, essentially. And that last number is going to be a 1.0. And then again, times 2, and I got 70.5, and they got 70.6. Again, I'm not worried about that. Seems like it should be good to go. Midpoints. Now, the midpoint is going to be even harder to do because you're actually looking right here in between those two for a height. In between for a height, in between for a height. Again here, right here in the middle for the height. A little bit easier to see there. And this one here. So this would be a 10. This is going to be a 12. And so you're looking right here at 11. And an 11 height, it's about right here. And that's what I take for my height to find my rectangles. And so it should be a number between the other two. I would not just say add them up, divide by 2, because it should be about an average. That is not correct. So these these are not the same numbers at all. You'll have to redo everything. So go back to the graph, 8.9, 8.5, 7.75. If it wasn't hard enough on a value, now you're doing it in between values, and it's just getting worse and worse. Did I mention math prison? So I'm trying to make this, good. I don't want to discourage you, but at the same time, it's just not a very happy problem. It's not a very happy section. And so I got 78.8, and you know what they got? That's right, 79.4. Now, I'm a little bit more leery about this one. I don't know if I would be happy with this. I'm not happy with it, but I mean, that's the best I can do. So I have a little note here for the midpoints. You're using x equals 1, 3, 5, 7, 9, 11. I was already telling you about the 11. For the left and rights, you're going to be using x equals 0, 2, 4, 6, 8, 10, and 12, depending on if it's a left or a right kind of situation. I have a note here. It says, so you can see how it will be difficult getting exactly what they got. Okay. Point stated, 51005. So I have f of x is equal to 7 plus 2x squared, and I'm going from -1 to 2. Okay, I would just, if they're looking for area and all that kind of stuff in this case, I would just say integrate it, call it a day, and you would get the most accurate answer. It would be a very simple way to get this problem. Again, all we're doing here is just some basic integral calculus, which at this point you probably could just do this problem on your own, just with the very short tutorial that I gave you just a minute ago. But regardless, we're trying to be very good and do what they say. And so they're saying find R3 and then find R6. And so I'm supposed to cut this up into 3 rectangles. And if you do a number line, -1, 0, 1, and 2, you could see that I have 3 rectangles. So basically a 1 distance between them. If I'm going to be doing 6 rectangles, I'd have to cut each one of those in the middle. So you'd go by 0.5s. And so this is how it's going to roll. So my R3 is going to be equal to f of -1. Plus f of 0, plus f of 1, plus f of 2, and then all times 1 because that's your width. And so I'm taking the -1 and plugging it in, taking the 0, plugging it in, taking the 1 and plugging it in. 7 plus 9 plus 15. Hold on, I messed up a small bit. Pause, back up. Okay, hold on. This is actually a good stopping point. Hold on. I messed up tiny bit, just a tiny bit here. I was forgetting the fact that we're doing R3. That means on the right side. And so whatever this curve is, it's a parabola, something kind of like this. And I'm trying to find this area here. I'm actually going to be using heights or rectangles from the right side. So there's your 3 rectangles, but here I'm choosing the right endpoints for the heights. So right here, and right here, okay? How many heights do I have? How many rectangles do I have? Well, I don't have 4. I only have 3 rectangles. So why do I have 4 numbers here? The thing is that one of these I do not need. And so if you're looking, I'm actually using here. I didn't draw it very well. It's not here. It's actually at 0. But I'd use the 0, the 1, and the 2. Values here. Let me just reorient it. There you go. There's your 0. There you go. So we got 0, 1, and 2. And so I don't use the -1 in my calculations. And if they were to say an L3, then I'd use this one, and this one, but not the 2. So I was a little overzealous, and that's okay. I'm just making a point here that we are using all the numbers at some point, probably, but in this particular case, they only want the right. Plugging it in 7, 9, and 15, and then again all times the 1, and I got 31, which is the most inaccurate answer. We could have got a more accurate answer from doing it this way, and we would have been done a long time ago. Now, for R6, very similar situation. I do not want to include the -1. I'm going to actually be starting at -0.5, and then 0, and then +0.5, and then 1, like 0.0, and then 1.5, and then finally the 2, and then all of this times 0.5. We're not multiplying by 1. This was the width. The width now is a 0.5. Lots of smaller rectangles here. And so I'm going to just plug all this stuff into that function up there again. 7.5, 7, 7.5 again, 9, 11.5, 15, and then times the 0.5. And so we got a 28.75, which is more accurate. It's a more accurate answer than the last one, but still not good enough. If we wanted to be the very most accurate and still do it this very silly way, I'd have to make 100 rectangles and then divide by a very tiny, or multiply by a very tiny number, and it'll eventually work. I have a note here, and this is very sad. I'm very sorry. It says repeat this entire process for L3, L6, M3, and M6. I will not be doing that. I'm very sorry. It's more of a time thing. I can just make that excuse. And so, let's keep going. 0, 2, 4, 6, 8, and 10. And then we have some 8.8, 7.5, 6.7, 6.4, 5.6, 5.1. All right, now they're looking for a lower estimate and then an upper estimate. So the lower estimate is going to be these guys. In fact, whoa, let's use a different color. That way we're all clear on this. So these will be my lower estimate. And notice that I'm jumping by 2's each time, right? And so then I'm going to have the 7.5, 6.7, 6.4, 5.6, 5.1. I'm going to multiply it by 2. And I got a 62.6. Now for the upper estimate, just like every other time, I'm only going to use these guys here and multiply by the same thing in the end. I do appreciate what they're doing here. I believe that this style here is, it's good. It's good to know. But I think that it might not be good for Section 1. There's different styles of learning. And my particular thought process in this, being your teacher, is that I feel that we should probably have small victories. That's what I call them, small victories, where you're able to integrate x squares, add 1 to the power, divide by new to power, and you feel happy about this. And then you do something else a little bit more complicated, and you're like, oh no, now what do I do? And you can build on these concepts, and it's all good because that is what you're going to do eventually. You're building on those concepts immediately, like Section 1 instead of Section 4. So I'm a fan of that style. This is all good. I would put this later. I would say, hey, come back to this and let's learn what really is going on besides all this. Imagine it like driving a car. So do you have to learn about how the engine runs and how you have a carburetor or the fuel injectors, and then you have your alternator and you have your water coolers, your water pumps, you got your fuel, you got all these things that you have to learn just in order to the gears, the automatic versus manual transmissions, how the tires rotate, and all these things. Or could I just put you in the front of the car and say, well, there's the gas, there's the brake, and this is how you turn? You know, I don't know if you are a car guy. I'm not, but I only know that stuff because of later I was interested in it after I had already been driving. Ahem. So, sorry for that small rant. It makes me feel better. I hope makes you feel a little better, hopefully. Um, so, they have this graph here where we're going a certain speed, kilometers per hour, and then seconds, and they want to find, using the midpoint rule with 6 subsections, find out the distance traveled. So this is the velocity. We already saw this over time, and so then basically I'm integrating it. I'm finding the area to find the actual distance that was traveled. This is going to be a little strange in the end, but just hang on tight for a second. I got 6, and so if you split this thing up into 6, then I believe you'll have it every 5 minutes. So there'll be a 5, a 10, a 15, that was a bad 15, a 20, a 25, and then a 30. Well, and this is not good enough, because of course it's not good enough. They want you to find the values at 2.5, and then at 7.5, and so on and so forth, to find those heights of the rectangles. So you're doing the midpoint rule like this. So you're still adding 5s, but you started off a little bit, and this is not friendly. This is not what we're doing here every day for the rest of your calculus life. So, but it's fine. It's fine. So what I want to do is find out what this value would be. I'm going to find all these heights, and I'm the professional height finder at this point. Of course, I know exactly what heights all of these are at by just looking at the graph. It's just so obvious. It's just so obvious that this is definitely the heights from this graph, right? I mean, everyone could see that that is clearly a 15. Clearly. Moving on. That was sarcasm. So 30 seconds is kind of weird because they're actually talking about hours. So we need to convert these seconds into hours, and that's why it's kind of weird. So we have a 5 distance between each one still, 5 seconds. But in order to actually get hours, we have to divide that by 3,600. So this is converting it into hours. And I went and did the math in a scientific calculator, and I got this guy right here. Cool. Well, so I went and did all that, and they have 0.36, and these are kilometers. Again, we found a distance traveled. I'd say mine was fine. And again, it's off by a little bit. If WebAssign is telling you these things are wrong, you better tell me. Just send me and ask my teacher, or email and say, hey, something's broken here. I mean, it was somebody just in my Cal2 class this semester found something broken on one of the problems because it wasn't allowing a simplified or an unsimplified version. It was just a wrong problem, and so these flaws still exist. Talk to me about them, and we can figure them out together. All right, 51013. They're finally talking about Riemann sums. And so let's go back to the car analogy for just a minute. Let's just say that I was saying, well, you need to learn about how the engine turns over, and you have to have the fuel injectors versus the carburetors, the manual transmission versus the automatic. You got to learn about your clutch and all this other kind of stuff going on, and not just on the surface, but like how it actually interacts, your alternators, all those car stuff. So we got all this car stuff that you have to learn before you even jump in the front seat of the car. Well, Riemann sums is now that we're going to be doing the chemistry of the combustion within the piston of the engine. So this is even deeper, where we're going to be using hydrocarbons with oxygen at certain percentage levels so that we can get result in fire, which results in the thing going up and down. Basically, this is the very nitty-gritty, sciencey part of of integrals. And so you'll be using this a whole one time in your life, and you'll never see it again. And that's fine. I'm going to teach it to you because they're going to talk about it. I think that's fine. It's a fine subject. But not the end of the class for sure. So an interesting thing here, if you are, let's say, like a pure math major, then yeah, you'll be seeing Riemann sums again for sure, and that's fine in other classes, not at Central Texas College. So, and that's okay. When you get there, you can relearn it in full because our class, our book, our problems do not do enough anyways, and they shouldn't because this topic is not for everyone. Did you understand this? Come on, there's my formula for Riemann sums. Obviously, everyone understands this. And how to apply it, right? So, this particular problem, do I have a number for this one? Yeah, I already put the number up there. They give me f of x is equal to x squared plus the square root of 1 plus 2x. And they're saying go from 3 to 5. And I'm telling you, here in some amount of time, all you're going to do is integrate this. And this is actually a very simple integral. We could do this in about 3 steps. And you would get an answer, and everyone's very happy about it, okay? This is good. We like this. It'll come soon. What they're wanting to do is set this Riemann sums up so that perhaps if you were daring, then you could actually go and find out how to do this on your own one day, maybe, kind of. So we have an f of x, and there's an f of x kinda. Okay, we have a delta x, which we have to figure out. And what they're having on the actual problem is limit as n goes to infinity of the summation of I equals 1 to n. I don't know why I have an infinity here. I meant to have an n here. I'm very sorry. That's an n. Anyways, that's an n. And then they have a big box, and we're supposed to fill it in. What's going in the box is this stuff here. Here's the idea. I have some kind of graph. I'm just making up a graph right here. And let's say we're going from here to there, and we're going to add up all this area here, right? That's going to be the goal. What we've been doing so far is finding these rectangles, and we're going to add up all the rectangles, and we'll get an answer that's pretty close to the full area. Of course, we got some margins that are not exactly right. And so what I'm going to do is make even tinier rectangles. Basically, I'm going to cut those rectangles in half, and that way I can get even more rectangles and a more accurate answer, and there's less margins that are missed. Well, I'm going to go so far as to basically just put a single vertical line for each one of these, okay? Now I'm going to ask you, what is the width of a single line? Right here, what's the width? And it's infinitesimally small. It's very tiny. It's near zero. It's nearly zero, as in like the limit as distance goes to 0 or something like that. How many rectangles, how many lines do we have to use in order to fill this up? And I'm going to say you basically have an infinite amount of lines to be able to fill this up. I mean, my lines will definitely start filling things up, but I mean, look, I'm drawing so many and I'm not close yet. I'll sit here all day trying to fill it all in with lines. Eventually I will, I guess, maybe. So that's infinity. So as my n goes to infinity, my delta x is going to 0 because the distance between them is near 0 and all that kind of stuff, okay? And then we add up all these lines, add them all up, and then we get an answer. That's what they're trying to say. Or you could just do the add 1 to the power, divide by new power. Okay, so what do I put in this box for this problem? First off, we need to be able to create our 2 separate formulas. And so I'm going to say first off, we have our 5 minus 3 is going to be a 2 distance for the entire problem. So from 3 to 5, there's a 2 distance. Your x sub I follows this formula. 3 plus 2i over n. Okay? That's going to be the start, and that's going to be the distance. So this is actually a formula that you'll need. Then we have delta x, which here's kind of another formula, 2 over n. Again, That 2 comes from right here. It's always divided by the n. In this case, in the cases that we're going to be seeing in this class, there you go. Here's your formulas. And so you're looking for f of x sub I. You are literally taking this right here, and you're going to plug it in wherever you see an x. You're going to multiply this on the outside, and you're done. And so what do you fill in the box with? And do not try to simplify, because that would take way too long. This was our original, okay? So we don't want our original. What we want instead is to replace it with the x sub I. That being 3 plus 2I over n, and now all that squared, square root of 1 plus 2 times 3 plus 2I over n, and then all that squared, and then the entirety of this thing here should be multiplied by the delta x, which is 2 over n. This, I'm not kidding you, all of this is exactly what you type into WebAssign as your answer, okay? This is what you're typing in there. Do not simplify. Do not try to simplify. You do not need to simplify. That is your answer. Okay. Oh, sorry, I didn't. Sorry. Right here. That's not your answer. Now it's your answer. Now it's your answer. There was not a square there. That was my bad. I'm sorry. I'm sorry. Always watch to the end. Small things like that. Okay, cool. So, did you learn anything from typing this into your homework? No. Did you learn something from here? Maybe. Maybe. Welcome to Math Prison. So, we're done with this section. I'll do another one here shortly. Thank you very much. Have a great day.